In geographical data, map can represent a very different thing. The same way the numerical data, the quantitative data, could mean very different semantics. So this kind of meaning may affect the way we design the mapping quantity measures. That's why we need to discuss the variety of quantitative data in this particular topic. Quantitative data may represent the count or the amount of some numbers totaled on area or totaled on a feature. Count is a number that can be arranged. Values with similar counts may show different or may show similar features or desirable features. The amount is similar to a count, but is more kind of measurable quantity that associated with features. Whenever we calculate the aggregate values for area, we may also get the total amount. Amount is usually is uncountable. So using count or amount will allow us to see the actual value associated with features on area so that we can compare. The map on the left shows the business with the number of employees as visualized as different size of circles. Again, this one allows us to see a count of employees per business. And the map on the right, we see these different parcels, and the parcel has different kind of land use value. We could also map the ratio between two variables to create something that shows differences between large and small. The most commonly used ratios are average, proportion, and density. For example, we can calculate the average number of people per household by looking at the attributes of this population data we have for population for each census tract, and then we also know the number of households in the census tract. So if we divide that by the population count, we're going to get a number called people per household. By mapping that number, we will be able to compare different areas by this ratio, which may reflect very different patterns. The map on the right shows an example of using a proportion as a way to show the data. Here we have the population total, but we also have the population breakup into the age. If we want to find out what percentage of the population that are within the age of 18 to 29, and we can easily create a percentage value by dividing the age group population to the total population. And that will give us a clear idea of the proportion of that age to the overall population. In other cases, quantities may represent a ratio that means a relative relationship between two numbers. We can derive ratio by dividing one quantity by another for each features or for each areas. So using ratio can make a large difference be more reasonable. For example, instead of seeing the absolute change over years in crime, we can look at the percentage change over years. That make the data as more palatable. One of the popular use of ratio data is to derive and map quantity as the densities of area. Because when we try to map the count and amount over areas, many cases because the number are sensitive to the size of the area, which kind of distort the results or give people illusion. But the density per unit areas or unit space can give you much better truth in terms of the distribution. The third type of numerical data is called rank. Ranks represent some kind of order from high to low or from the best to the worst. So this kind of value give you the qualitative idea of how the feature compare. And in many cases, we apply the ranks to the measurements where we can hardly say the absolute value, but it's easier for us to compare. For example, this map again shows the streams or rivers that is ranked by the recreational value in relation to fishing, etc. Some of the rivers are rated as excellent, other rivers are rated as good or fair or poor, and we can use numbers like a 1 to represent excellent, 2 to represent good, or we can use a scale from 1 to 10. We can use 10 to represent the best rating, excellent, and we can use 5 to represent fair. So these are all possible, but ranking is really reflect the qualitative sequence or order.